Good to have you on Models and Agents, episode 74 on June 8th, 2026. Let's see what shipped. New week in AI. And if last week was anything to go by, buckle up. Let's get into it. Enterprise agents just gained a built-in factuality check that keeps requerying until multi-hop questions have enough evidence. Google Research added a sufficient context agent to the Gemini Enterprise Agent Platform. The agent repeatedly issues new searches until collected passages provide enough grounding for multi-hop, multi-source questions. This raises factuality accuracy by as much as 34% compared with ordinary retrieval augmented generation pipelines on the same queries. The approach targets enterprise deployments where hallucinated multi-hop answers create real risk. Builders working on research or compliance agents should test the new capability against their existing retrieval stacks this week. This development fits into the maturing agent and tool use arc, where reliability of long horizon agents remains a key open question the show continues to track. Local inference users can now combine DFlash speculative decoding with KV cache compression on Chwen 3.627b for up to 3.26 times throughput on an RTX 5090, while keeping perplexity within 0.04% of baseline. Open clinical de-identification and VLLM monitoring tools also dropped today. Google Research released an agentic retrieval augmented generation framework inside the Gemini Enterprise Agent Platform, built around a sufficient context agent. The agent repeatedly issues new searches until the collected passages provide enough grounding to answer multi-hop, multi-source questions reliably. This raises factuality accuracy by as much as 34% compared with ordinary retrieval augmented generation pipelines on the same queries. The approach is aimed at enterprise deployments where hallucinated multi-hop answers create real risk. Builders working on research or compliance agents should test the new capability against their existing retrieval stacks this week. Watch for whether the same requery loop appears in consumer Gemini interfaces or open agent frameworks. Chwen 3.627b with DFlash speculative decoding and KV cache compression on an RTX 5090 reached 3.26 times throughput using the Q40 Turbo 4 strategy. Perplexity on Wikitext 2 stayed within 0.02% of the KQ8 VQ51 baseline. Q5KXL quantization outperformed NVFP4 Q80 across every tested KV strategy, delivering both higher baseline tokens per second and better scaling under compression. The drafter model achieved 30 to 51% acceptance rates thanks to cross-attention rather than token-by-token speculation. Code quality on Tetris generation tasks actually improved slightly under the best compression setting. This update narrows the open weight performance gap while directly addressing inference cost curve questions the show has been following in AI compute and inference. Medis released an open multilingual clinical de-identification model and synthetic dataset designed to strip patient identifiers while preserving symptoms, labs, medications, and treatment timelines. The model was trained on dynamically prompted synthetic notes that vary language, document type, length, and identifier families to match messy hospital exports. It is available on Hugging Face along with the dataset and an interactive demo extractor. Hospitals still need policy and audit layers around the model, but it provides a reproducible starting point for privacy-preserving clinical pipelines. Google's Gemma 4 QAT Q40 GGUF files for the E2B and E4B variants contain additional per-layer projection tensors that are absent from larger 12B plus checkpoints, and from Unsloth's UD-Q4K-XL equivalents. The Google Q40 files are larger on disk than Unsloth's Q4K-XL versions, despite the nominally lower precision, because the extra tensors are stored at higher internal precision. Users analyzing GGUF structure with Kobold CPP or Llama bundle tools can now compare these layouts directly. Recent open checkpoints now handle multi-object spatial relationships and short text rendering at roughly 70 to 80% reliability. 2 megapixel images can be generated in under 2 minutes on a single consumer GPU, when resolution and step count are reduced for iteration. The post argues that structured prompting, often viewed as a limitation, is actually what production pipelines require. VLLM Doctor is a new open-source command line interface that pulls metrics from a VLLM at metrics endpoint or Prometheus and runs rule-based checks for queue pressure, high time to first token over time, per output token, and KV cache exhaustion across pods. Each diagnosis includes the triggering metrics, confidence level, likely causes, and concrete remediation steps. Output is available in human-readable text, or JSON, plus a watch mode. The project is still early and welcomes feedback on missing diagnoses. Install from the GitHub repo and point it at any running VLLM server to start. The full benchmark scripts, config.yaml, raw data, and generated Tetris artifacts from the dflash plus KV compression tests are available on request, while the author prepares a public GitHub repo. Reproduction commands cover perplexity on Wikitext 2, coding task throughput, and code quality scoring. Anyone running blama.cpp with dflash support can request the exact model keys used. Okay, let's pop the hood on this one. Everyone talks about speculative decoding as a simple speed knob. In practice, it is a tight coupling between drafter size, acceptance rate, and KV cache layout that only works when the drafter and target share enough cross-attention structure. The dflash approach replaces token-by-token speculation with a single cross-attention forward pass from a smaller drafter, which is why a 5-bit drafter can still propose useful sequences at 30 to 51% acceptance. Adding KV compression on top changes the memory bandwidth trade-off. Q40 Turbo 4 keeps perplexity statistically identical to the KQ8VQ51 baseline, while cutting cache traffic enough to reach 3.18 times throughput on an RTX 5090. The quality gain disappears once the drafter's acceptance rate falls below about 25%, which is why Turbo 2 TCQ variants show both higher speedup and measurable perplexity degradation. Run the compressed path on memory-bound local setups. Fall back to full precision KV when you need maximum acceptance on long context agent traces. The gotcha that bites most teams is assuming the drafter and target quantizations can be chosen independently. Mismatched layouts destroy the cross-attention benefit. Run the Q40 Turbo for dflash configuration on Qwen 3.627b if you need faster local coding agents without measurable quality loss. Test Medi's PII on your own synthetic clinical notes to see how well it preserves lab values and medication timelines while stripping identifiers. Point VLLM Doctor at any production VLLM endpoint to surface KV cache pressure before it causes timeouts. Compare Google's Gemma 4 QAT Q40 GGUF against Unslot's UD-Q4K XL on the same E4B checkpoint to measure the effect of the extra projection tensors. Further releases of Gemma 4 QAT variants at additional sizes are expected in the coming weeks. A public GitHub repo with full dflash benchmark scripts and artifacts is scheduled after cleanup. Expanded agentic retrieval augmented generation patterns are likely to appear in open frameworks following the Gemini Enterprise announcement. Tomorrow, keep an eye on whether the sufficient context agent pattern surfaces in open agent frameworks or consumer Gemini interfaces. That's models and agents for today. If you found this useful, share it with someone who's trying to keep up with all these changes, and subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow, and before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give environmental intelligence a listen, the Environment and Climate Policy Brief for Canada. You can explore the whole lineup at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.